Today we're going to take a look at the surface areas and volumes of similar solids. In the exploration or warm-up that you did today, it stated that similar solids are two solids of the same type with equal ratios of corresponding linear measures such as heights or radii. And you took a look at two similar triangular prisms. As we learned last class, the ratio of corresponding perimeters is the same as the ratio of your corresponding sides or segments. And again, that was called the scale factor similarity ratio. And then the ratio of the areas of two polygons was equal to the square of the corresponding segments or side lengths. So in the exploration, when you took a look at the volumes of the triangular prisms, you discovered, or should have discovered, that the volumes now are the cube of the ratio of the corresponding segments or sides. So if we look at the theorem at the top of the page to fill in the blanks, it states that if two similar solids have a scale factor of A to B, then their corresponding areas, such as lateral areas, base areas, surface areas, again, keyword is areas, they have a ratio of A to B squared. And then the corresponding volumes are A over B cubed. Again, another way to write this would be using a colon. You could also do A squared to B squared and A cubed to B cubed. So in example 1, it says that the two right cylinders are similar. So similar, or cylinder, we can call this cylinder 1 and cylinder 2, they are similar. So that means that they have equal ratios between their corresponding radii and corresponding altitudes. So part A asks us to find the scale factor. So if I take a look at the ratio of the radii, which is given 8 over 10, reduces to 4/5. So 4/5 is my scale factor. Using this scale factor, we're going to find part B, the height of the larger cylinder. Now you could use 8 over 10, or you could use the reduced fraction 4/5, which is what I'm going to use. So 4 to 5 is equal to 12 to h. Again, some of you can see what h is going to be. Others may need to cross multiply. And we end up with 4h equal to 60. Divide by 4, and h is going to be 15. Again, some of you see that 4 times 3 is 12, so then 5 times 3 would be 15. So the height of the larger cylinder, part B, is 15 units. Moving down to part C, I now need to find the ratio of the base areas. And we just wrote above that the ratio of any corresponding areas is equal to the scale factor squared. So part C is going to be 4 squared to 5 squared, which is 16 to 25. Part D, it wants the ratio of the lateral areas. Well, again, any corresponding areas, whether it be lateral areas, base area, or surface areas, is going to be the square of our scale factor similarity ratio. So part D is also going to be 16 over 25. And then part E, the ratio of the volumes, we know that is equivalent to the scale factor cubed. So I'm going to do 4/5 cubed. 4 cubed is 64. 5 cubed is 125. Moving down to example number 2, it says the cylinders below are similar. find the scale factor of cylinder 1 to cylinder 2. Well, given in the question, it tells us that the surface area of cylinder 1 is 288 square inches, and the surface area of cylinder 2 is 120 inches squared. And we know, given that ratio, that when I take my scale factor, and I'm going to use A over B, you could use any two variables, and when I take that ratio and square it, that gives me the ratio of the areas. So 288 over 128. In order to solve for A and B, I need to take the square root to undo the square. And A over B equals, again, don't forget the positive and negative, and we're going to reject the negative as our ratio is going to be positive. And then I'm going to take the square root of 288 over 128. Now 288 over 128 is not, those two numbers are not a perfect square. So if I can reduce those two numbers, or reduce the fraction, I can see if I can possibly get two numbers that are a perfect square. So let's go ahead and open our graphing calculator. Which I do not see on. If you have a calculator, go ahead and type that fraction in. Remember, you can change any decimal to a fraction by doing math enter, enter. So 288 divided by 128, enter. Again, math, enter, enter. If you struggle or just want to be lazy and want the answer quick, that reduces to 9 over 4. Again, 9 over 4 is an equivalent fraction to 288. I'm just going to reduce it so that I can take the square root. And so now I have the ratio of A to B equivalent to 3 over 2. So the scale factor of cylinder 1 to cylinder 2 is 3 to 2. Last one on the front, we're given two cones that are similar. Find the scale factor of the smaller cone to the larger cone. So this is going to be similar to number 2. However, in order to get the ratio of the volumes, we have to take that scale factor, ratio of scale factors, and cube it in order to get the ratio of the volumes. So that's equivalent to 108 over 256. The pi's are going to cancel out. So now I want to take the cube root in order to undo the cube. Again, that's inverse of cubing is the cube root. So I end up with A over B equals, and we don't need the plus or minus out front, okay? Unless, if we were taking the cube root, for instance, of negative 27, we'd get the negative 3. But the cube root of just 27 is 3. So there's no two different roots when taking the cube root. They need to specify underneath in the radicand whether you're taking the cube root of a positive 27 or negative 27. So again, right now 108 and 256, those are not perfect cubes, but if you reduce that fraction, we can take the cube root of 108 over 256 is equivalent to 27 over 64 reduced. And 27 and 64 are both perfect cubes. So A over B is equivalent to 3/4. In example 4, it says the length, width, and height, so all three dimensions are going to be tripled. So that means they're going to be multiplied by 3. Describe the effect on the surface area and volume. So you can go ahead and actually triple all the sides and calculate your surface area and volume. However, we know that we're going to take that scale factor, which is 3, And for the surface area, we're going to just square it. Volume will cube that factor. So 3 squared is 9, 3 cubed is 27. So our surface area of the prism, or our new prism, is going to be 9 times as large. And the volume is going to be 27 times as large. I'll give you a minute to write that down before we take a look at example number 5. If you've already finished writing that down for number 4, go ahead and read example number 5. Now, in example number 5, it says that cones A and B are similar with a scale factor of 5 to 2. Find the surface area and volume of cone B, given that the surface area of cone A is 2,356.2 centimeters squared, and the volume of cone A is 7,450.9 cubic centimeters. We're going to round our answer to 2 decimal places. So let's compare in order of cone A to cone B. Again, I'm going to break it up into 2 columns here. Okay, so we're going to find the surface area and volume of cone B, given the surface area and volume of cone A. So for the first part, we know that when we take the scale factor of 5 to 2, and we square that, again because it's area, we get the ratio of the surface areas of cone A to cone B. The surface area of cone A was 2,356.2. So I'm going to put that over x and solve for x. So 5 over 2 squared is 25 over 4, equivalent to, again, 2,356.2 over x. Cross multiply. We've got 25x equal to 9,424.8. Divide by 25, and x is equivalent to 376.992. Rounding it to 2 decimal places, the surface area of cone B is going to be approximately 376.99 square centimeters. And again, to find the volume of cone B, we use the scale factor of 5 over 2, but with volume, we cube it. And that's going to be equivalent to 7,400 right here and 50.9 over x, because x represents the volume of cone B. So again, when I cube 5 over 2, we get 125. 5 cubed 1 over 2, or 125, and 2 cubed is 8. And that is equivalent to 7,450.9 over x. So I'm going to go ahead and move forward and cross multiply and divide by 8, or 125 as I did on the left side. So we get 125x equal to 5,900, or 59,607.2. Divide by 25, and x is equivalent to 476.8576. to 2 decimal places. To the right is a 7, so that's going to bump that 5 up to a 6. So the volume of cone B is approximately 476.86 cubic centimeters. Number 6, the last one. It says the surface area of 2 similar figures are given below. The volume of the larger figure is given. So I'm just going to note that this is the volume of the larger. We need to find the volume of the smaller. So I'm going to call that X. Okay. So in each, again, I'm going to note that I'm just going to compare the smaller figure to the larger figure. And if I start with what's given, my ratio of my surface areas, from that ratio, I can find the ratio of my corresponding sides. So A over B squared equals 16 over 100. And 16 and 100 are perfect squares, so I'm not going to reduce that. I'm going to go ahead and take the square root. Again, equals positive 4 over 10 and negative 4 over 10. I want to reject the negative. Now I'm going to go ahead and use that ratio to find the volume. Now you can reduce that. You don't have to. You can leave it as 4/10. But again, if it was asking for the scale factor within the question, you'd want to reduce it to 2/5. But you can leave it as 4 over 10s. So I'm just going to leave it as 4/10, and I'll show you also with 2/5 that you do get the same answer. So if I have it 4 over 10 cubed, that's equivalent to X over 500. And then also you should get the same answer with 2 over 5 cubed equals X over 500, because those are equivalent fractions. 4 cubed, 64, 10 cubed, 1,000 is equal to X over 500. So I end up with 64 times 500 is 32,000 equal to 1,000. X divided by 1,000, and X is 32. Cube 2, you get 8. Cube 5, you get 125, is equivalent to X over 500. Cross multiply, you end up with 125X, equivalent to 8 times 500, which is 4,000. Divide by 125, and X is 32. You get the same answer. So to answer the question, the volume of the smaller figure is 32 cubic centimeters.